In this last lesson on trigonometric equations, we're going to look at equations you might see in an exam paper. So this equation still has the sine, cos or tan element to it, but there might be a multiple in front of it, or a subtract or an add. There can even be things on the other side of the equation. In this case we've got a 0, there might be a 1, or there might be another sine x or so on. But let's look at the one we have here. Solve 3 cos x take away 1 equals 0 between 0 and 360 degrees. And from now on in these examples we're going to use our all sine tan cos to help us instead of drawing out the graphs. So the first thing we have to do with this equation here is rearrange it to get cos x equals. Once we get that, we just do exactly the same as we did in the previous examples. Now you can look at this equation similar to 3x take away 1 equals 0, or you can think about it as we want to change the subject of the formula to cos x. So the first thing we want to do, we want to get rid of this negative 1 here, or subtract 1. So in order to do that we add 1 to both sides. So that gives us 3 cos x equals plus 1. And finally, to get down to cos x equals, we have to divide both sides by 3. So this becomes 1/3, or 0.33333. So here we see that the cos of x is equal to a positive value. So we note that down to help us with our all sine tan cos. So when we're looking at this, we're looking for where the cosine wave is positive. That would be the A, because all the graphs are positive there, and also the C, because the cosine wave is positive there. So let's work out our base angle. Inverse cos 0.3333, and you get 70.5 degrees. Now to get our first solution in the first quadrant, you go forwards from 0, so that's just going to be our 70.5. And to get into the last quadrant here, you go backwards from 360. So 360 take away 70.5 gives us 289.5, and those are your two solutions. Okay, let's look at this next one. 9 tan x plus 3 equals 1. Give the solutions between 0 and 360 degrees. Make sure you have your all sine tan cos drawn out to help us with this. So the first thing I want to do is subtract 3 from both sides here. So that will leave us with 9 tan x, and 1 subtract 3 is negative 2. Then we have to divide both sides by 9 to leave us with tan x, so that would be negative 2 divided by 9, which gives you this negative 0.22222. And at this point we can see that the tan of x is equal to a negative value, so we write that down to help us with our all sine tan cos. So we're looking for where the tan graph is negative. It's not the first quadrant because all the graphs are positive. In the second quadrant, only the sine is positive, which means tan and cos are negative, so that's what we're looking for. The t means the tan graph is positive. We don't want that. We want the tan graph to be negative. And the final quadrant, only the cosine wave is positive, which means tan and sine are negative. That's what we're looking for. So let's work out our base angle. Remember to inverse tan the positive value here. So we're using 0.222, and that comes out as 12.5. We're not going to inverse tan the negative value here. That would give us an angle larger than 90 degrees, which we do not want. Okay, to get our first solution, which is in the second quadrant this time, we take the base angle away from 180. So 180 subtract 12.5, and that gives us 167.5. And to get into the last quadrant again, you go backwards from 360. So that would be 360 take away 12.5, which gives us 347.5.